Hello and welcome to Class Time. I'm Denise Bailey.
And I'm Shadeen Cassie, and we are your math teachers for today's CSEC mathematics lesson. Let's begin.
So today we will be looking at linear inequalities. And that is a topic that is most interesting and will take you through. The objective is that at the end of the lesson, you will be able to represent the solution of linear inequalities in one variable using set notation. To start off our conversation, Shadeen, equations and inequations, is there a difference?
Those two words, they sound so similar,
Okay.
Yet opposite to some extent. Equations, we talk about maintaining a balance,
Okay.
where one set of expression is equal to another. And while for inequation, then there is some amount of imbalance.
Okay. And this picture here would represent what? When you talk about the balance.
All right, this is saying 2 plus 3 is equal to 5. So right there we can see that this is an equation.
Okay.
The right-hand side is equal to the left-hand side.
Okay. And if that is an equation, then this would have to be the inequation.
That is the inequation.
Okay.
Right there you can see some level of imbalance right there.
Yes. And so we have rightfully identified
The
equation, the use of the equal sign, both left and right-hand side are balanced, they are equal, while the inequation there is some amount of imbalance with the right-hand side and the left-hand side. Right. Okay, so we talk about equations and inequations. Where does the word inequalities come from then?
All right, so we see inequalities coming up from inequations.
Okay.
These are the symbols that we use to refer to the imbalance.
Yes.
Right?
Yes.
So each symbol here symbolizes something different.
Okay.
The first one shows us that it means is greater than.
Yes.
We can see that the opening points to the larger amount.
Okay.
Right.
Okay.
The opening of the sign. The next one, yes.
So the example?
The example is x is greater than 1.
And it is red. It looks like, and it is red, x is greater than 1. Okay.
Good.
So if that sign there, the first sign is greater than, then this sign is, of course, is less than.
It is.
And again, the opening of the sign is open to the side that has more. But reading from left to right, we see that the rays converge to a point, pointing to the side that has the least. So reading from left to right, we would say x is less than 10. This is what it looks like.
Right.
And this is how it is read. Okay.
The next one is the sign that's there. There is a line under the is greater than sign.
Okay.
And it's saying that is greater than or equal to.
Okay.
So there are situations where it could be the same amount or greater than.
Okay.
And that is also classified as an inequation.
Okay.
Right.
Okay.
The example states that x is greater than or equal to -2. And it is read from left to right. X is greater than or equal to -2.
And what I'm understanding in whatever solution set there is, -2 is a part of the solution set.
Right, for this example it is.
Okay, for this example. Okay. And of course we have the is less than or equal to sign. It is similar to the is greater than, but the opposite.
Right.
That makes sense?
That makes
I hope
sense.
you understand what it is we're saying. And it is, as is in the example, x is less than or equal to 12. And this is how it is read. Okay, so you see it in the use of symbols, and you see it with words written, right?
Denise, when we talk about more than or less than, then this is where these signs come into
Yes,
play, right?
yes.
So mathematically speaking, we refer to them as is greater than, but we're really talking about more than.
Okay,
Right.
okay, yes. Just in case some persons have a little confusion, right? So we come now to what we call linear inequality. And I want us to appreciate what this means. A linear inequality is in one variable is an equality which can be written in this form. AX added to B is greater than C, where A, B, and C are real numbers, and X is an unknown value or a variable. Question though, in the symbols that we looked at earlier, we had is greater than, is less than, and all of those, but this says is greater than.
All right, so the sign will change based on the situation.
Okay.
Right, so for this is just like a generalization, but the signs change to suit each situation.
Yes.
So it could be AX plus B is greater than or equal to C, and there is an example,
Okay.
6x plus 4 is greater than or equal to 15,
Okay. Okay, and we could have
AX plus B is less than or equal to C,
is less than C.
is less than C,
Yes.
and the example is 2x plus C is less than
so
9.
2x added to 2
Whatever
is less
value
than.
you get should be less than 9.
Okay, thank you. And if that is true for those two, then here we have another example.
AX plus B is less than or equal to C. And the example is 3x plus 2 is less than or equal to 21.
Okay. Okay, so the solutions, working with those examples, and now we understand and can appreciate the symbols and what they mean and how linear inequalities are represented, we're going to look at the solutions. The solutions for linear inequalities is a range of values. You know, it's a set, a range from one start point to another, and otherwise this is called a solution set. Now, the solution set, we can show the range in the solution set by using what we call set notation. And the set notation that we have, this is what it looks like, the set notation, and this is what it says.
Okay.
It says the set of all x
Such
that, represented by the colon, and in some instances there is a line,
Yes.
such that x is greater than 4. So what does that mean? What does this really mean?
It means that all the elements of this set are numbers that are greater than 4. So
Okay.
there is not just one number, but a set of numbers
That will fit.
that will satisfy this.
Okay, okay. I can understand that, and that is quite interesting for us. And look at it, if this set as defined is a set of all real numbers greater than 4.
Right.
Okay, and of course,
This can also be represented on a number line, right? So there we have array with an endpoint starting at 4 and the arrow extend in the direction of the right.
yes.
Right, so we are thinking about all those values that are to the right of 4.
Okay.
And this is how we represent our solution on a number line.
On a number line. So just to recap, we have we can represent it
ways
in the
of-
set notation,
Right.
and we can use the number line to assist us in identifying or clarifying or understanding.
Good.
Right? Okay.
We can also choose to list the members of the set.
Yes.
Right?
Yes.
So we could have gone ahead, use our curly brackets to identify the elements of this set. And for this case, it would be an infinite set, so it's 5, 6, 7, 8, and it continues. So if we think about 1,000, it falls in this
So
set.
how do I know that this is an infinite set? When I look.
It is array, so there is no endpoint. It extends in one direction.
Okay, fair enough.
And
I'm also looking at the notation of the listing of the sets.
And
I'm
the
seeing
3 dots.
the 3 dots known as ellipses, which suggests that the set goes on to infinity.
Right.
Okay. Okay. Okay, so that's not bad. So let us look at inequalities. We have been exploring this whole idea of inequalities and solution sets and how it is we write the solutions using the set notation, using the number line, and even listing the elements of the set. I ask you kindly to help us to understand and work this. How is this inequality read? And next we solve it. What do we see?
All right, so we would have been looking at the inequality signs, right? And we can identify that one of those inequality sign falls in this inequation.
Yes.
And it is the greater than or equal to sign.
Yes.
Hence, that inequation is read x plus 2 is greater than or equal to 7.
And some would say x is added to 2 or x added to 2 is greater than or equal to 7. Okay, so we have that out of the way. How do we solve this inequality?
All right, so when we are solving this inequality or inequation, we are really thinking about the equation as well as the inequation.
Okay.
The difference will come into play. So for the equation, we have the equal sign. In this case, we are working with an inequality sign.
Okay.
Now, how does that differ? There is not much difference in solving this problem from solving an equation.
Okay.
All right, so let's move into solving on the board.
Yes, please.
So it's x plus 2
Is greater than or equal to 7. Yes.
Now, when solving, we try to maintain our balance while we are transposing, or we are trying to make x the subject of the formula.
Okay, so we want to balance whatever we do on the left-hand side.
We also do it to the right-hand side,
okay.
whatever operation is being carried out.
Thank you.
So it's x plus 2. And in order to transpose, we're going to carry out the inverse operation.
Yes.
So we are going to be subtracting 2.
Okay.
And this is what we are including in the inequation. So we are also going to be doing it to the right-hand side.
Yes.
Now, x here, we will be left with 0.
Yes.
Because 2, and we're taking away 2, will give us 0. So we could add the 0, or some person can choose to not include the 0.
Yes.
So I'm going to eliminate the 0 right here.
Yes.
And that is greater than or equal to 7 take away 2.
5.
And that's 5.
Okay. So what does that
Our
mean?
solution is x is greater than or equal to 5. So we are thinking about all those numbers that are greater than or equal to 5. Question, should 5 be included?
It's greater than or equal to? Yes. It says or equal to.
Right.
So 5 is a part of the solution set.
set.
Okay then.
So we could go ahead and list some of the elements of this set. So it would be,
starting with 5.
so
6.
it's greater than or equal to, so our starting point is 5, 6, 7, 8.
Yes, ellipses, because of course,
The set is an infinite set.
Okay, so what I'm understanding is any of these values, when plugged into that solution, into that inequality, will make the inequality true.
Right, and we can go ahead and test to see that what you would have just said is actually true. So I'm going to be taking randomly, I'm going to be taking
6.
6.
Yes, please.
So I'm going to make a note that we are proving our solution. So it's a proof. So the inequation that we are working with is x plus 2
is greater than or equal to 7.
And we are going to say x in this case is equal to
So we let
6.
x equal 6, okay.
So we are going to be substituting.
Yes. Wherever we see x, of course, we put the 6.
Right?
Yes. Greater than equal.
So 6 added to 2 will give us 8. Is 8 greater than or equal to 7?
It is.
It is.
And so it is correct.
And so it is correct.
Okay. Okay. So if we are to represent all of that is on the number line, we see that, let's look at it, represented by a ray with a closed dot or a shaded dot at the end. The dot is on 5, and then the ray is pointing to the right to show all the values that would satisfy this inequality. What would this mean, though? What do you think it means? Remember, we spoke about greater than and equal to, and we asked the question, Shadeen asked the question if 5 was included, right? What do you believe that this shaded dot at the end of the ray actually means?
Because 5 is included, then here we have a closed. You refer to it as being shaded or
yes.
closed, but it is a closed dot to show that 5 is a part of the solution set. Denise, before you continue though, some persons would want to, the representation of the ray could be on the number line itself.
Yes.
But for clarity,
yes,
it's more suitable above to show instead of including it on the line
where
itself.
everything may be shaded and darked out. And okay, I can appreciate that. Now the set builder notation, the solution set is represented in the set builder notation, which says that, what does that say again? What does it read?
Is such that x is greater than or equal to 5.
And pay attention to this notation that is here. Look at how it is written. It has the curly brackets, and inside of the curly brackets, we have the variable that is represented, the sign, which is the colon. In some cases, there is a line that is shown, and the value x is greater than or equal to 5. Right. Okay. Okay, we can live with that. So let's look at this subtraction again. How is it read? And how is it read, and how do we solve?
It is read as x take away 3 is greater than 4.
Okay.
So remember, the opening shows the greater portion, and the closed end will refer to the lesser portion.
Okay. Okay, and if we were to solve this, based on what you would have done, and you have highlighted that there is no great distinction or deviation from how we would actually solve the other equations, we have on the left-hand side, x subtracting 3 is greater than 4. Whatever we do to the left-hand side, that is what we do to the right-hand side in an effort to make x the subject of the inequality. In order to make x a subject of the inequality, we identify, yes, that
we are going to be doing the inverse operation right here. And while doing the inverse operation, we are also going to maintain in the balance of the inequality.
Okay.
Right. So here,
yes,
becomes a 0.
Yes.
Negative 3 plus 3 will give you a 0. So we are left with x, and that is greater than
a 7.
7.
Okay, so I can see the solution sets coming out now.
Right.
Any
number
that is
greater than 7
would satisfy this inequality.
Right. And we could narrow it down to say any integer.
And okay.
Right.
Okay. So we are defining the set. Not a problem. And of course, again, how would we represent this on the number line? Here we have identified that x is greater than 7. In the first example, we had used an array with a dot, closed or shaded at the end. I wonder if we're going to still have a closed or shaded dot at the end.
All right, let's see.
Let us, in this case then, the unshaded or open dot means what?
That the endpoint of the ray is not included in the solution
It's
set.
not a part of
It's
it.
not a part
so
of
I
the
can give
solution
any
set.
of the
Right.
integers or the numbers on the number line that I'm going to the right, but I am not to include the 7 because
It's open.
it's open. It shows that it is open and it states is greater
Greater
than. Okay, I can live with that. So I wonder what the set builder notation would look like.
So
Again,
it is
yes.
x is such that x is greater than 7.
Yes.
Yeah.
Yes.
So it's not much different
No.
other than say the sign that's different there.
Okay, and we can live with that, and we can appreciate that. So just to recap,
Just to recap. So earlier we looked at the closed dot and the open dot, right? So for x is greater than or equal to 5, the dot is closed, which symbolizes that 5 is included in the solution. And for x is greater than 7, the dot is open, which symbolizes that 7 is not included in the solution set.
we are to pay attention to these things because
That's important.
Yes,
And
correct.
can I add to that, should it be a case where it is x is less than or equal to, then the dot would be closed. And if it is x is less than something, the dot or the endpoint will also be open.
Okay, okay. And of course, the array moves is pointing to the right simply because
It is greater than or
it
equal.
is greater than the stated
Yes.
endpoint that we have.
Yes.
Okay then, not bad. So ladies and gentlemen, I hope that for now you would have a greater appreciation, at least for the basics, as we work with inequalities or inequations, how to solve them, how to use the set builder notation, and how to represent them on the number line. Okay, okay. So here are our reminders. As was said before, as is read, a closed dot indicates that the endpoint is a part of the solution, while an open dot indicates that the endpoint of the ray is not a part of the solution. Okay. So let us look at the inequality with multiplication now. We looked at addition, we looked at subtraction. Let's look at multiplication. And what is read there, we have 4x is less than or equal to 12. That is what is read. As I said before, 4x is less than or equal to 12. And you'll take us through how we solve.
All right, so seeing that we are still on the basis or we are linking two solving equations, then we will take this as another inequation that's similar to what we would have done before. We must observe, though, that 4x is saying the same thing as 4 multiplied by x. And 4 multiplied by x is less than or equal to 12 in this case.
I thank you.
So it's 4x is less than or equal to 12, and we could expand for those who might have glitches.
Yes.
So it is 4 times x that is less than or equal to 12.
So
Now,
we'll still do the inverse operation.
we still do the inverse operation while we're trying to make x the subject of the formula. So the inverse of multiplication would be
division.
So we are going to be dividing by 4.
Okay.
And whatever you do to the left-hand side, you also do the same operation to the right-hand side.
To keep the balance.
Maintain the balance.
Thank you, thank you.
So it is x that is less than or equal to 12 divided by 4, 3.
Okay. Good. And the solution set would say...
We are thinking about all those numbers that are less than or equal to 3. And less than or equal to, I'm thinking about the closed dot. As well as I'm thinking about including 3.
Yes. Okay. And the position of the ray would be pointing to the right of the 3 or pointing to the left?
It would be pointing to the left.
Okay. 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 And we see there that this would be the number line represented, and here we have the set builder notation. We're going to take a quick break, But we will be right back with more CSEC mathematics.
Welcome back to class time. Let's pick up where we left off.
Okay.
Now, we were talking about the solution set for 4x is less than or equal to 12.
Awesome.
Right? And as read, x is such that x is less than or equal to 3.
Okay.
Denise, by definition, we were not given a particular situation to say that we are to identify integers for this solution set.
That's true.
Hence, we are thinking about all the real numbers that can satisfy this solution.
Yes.
And in thinking about such, we are thinking about going as close as possible to 3.
So
all the values going as close as possible.
So,
well, this case, we are including 3, right? So it would be, if we think about 2.5, 2.999, 3 as well, or 2.5. We can think about fraction. We can think about negative 5.5, negative 4 3/4, whatever you think about, a real number that will fit in this solution set.
Okay. I understand, and I hope you guys at home are understanding too. So we looked at multiplication just now,
Right.
but there's a clarification that we need to have before we move any further. We want to explore multiplying and dividing by a negative number when it comes on to inequalities. And so we want us to really understand what is happening. Look at what we have. 3 is less than 6. We have an open number line represented here. If we should think of the open number line, I can place the 3 to the left of the 6 to show its position in relation to the 6. So now the 3 is less to the left of the 6. Now, if we were to add 4 to both sides, because we're maintaining that balance that we spoke about,
That's right.
we would get, what would our new numbers be? We would get something like what, 7 and 10? Let us represent that also on the number line.
Right.
7 remains, 10.
To the left of 10.
7 remains, thank you, to the left of 10,
Yes.
which keeps the inequality, the sign, true, because of course 7 is less than 10.
Yes, it is.
Okay, good. What if we were to, again, representing the 3 is less than 6 on the open number line, what if we were to subtract 2 from both sides, both left-hand side and the right-hand side of the inequality? Of course, our answers would now become what?
1
1
and 4.
Okay. Now, when we look at the representation, we see that the 1 is still to the left of the 4, which is represented here by green. The inequality remains true because when 2 is subtracted from both sides, 1 still is less than 4. Okay? And there it is. It remains true. Now, we want us to have that proof right there because we're moving a little further. If we were to, let's say, multiply positive numbers, multiplying by 3, of course, we know that the 3, which is less than 6, the 3 multiplied by 3 would give us
9.
and the 6 multiplied by 3 should give us
18.
18. And it holds true because the 9, remember the red dot here is representing the number, the value that is in the less position, right? And it remains true. But what actually happens if we are going to multiply or possibly divide by a negative number? Let's look at this. Again, we have the 3 is less than 6. Let us divide by negative 3. Talk to me.
3 divided by negative 3 will give us 1.
1 or negative 1?
Negative 1.
Okay.
And 6 divided by negative 3 will give us a negative 2.
Okay.
We are dividing
Look at the
a positive
by a negative.
Hence, our solution is a negative.
Okay.
Right.
And look at the positions. This is the original that we have. The 3 remains less and the 8 remains more, as is their position on the number line. When we input the answers, however, look at the positions. Look at what happens.
There is a reverse.
Look at what happens. There is a reverse. No longer is negative 1 less than negative 2. So to hold the inequality true, there has to be in the streets, I know you guys talk about the flipping, the reorientation of the sign
the
that is
inequality
there.
sign.
Thank you.
Yes.
So let me say, according to Shadeen, the reorientation of the equality sign. The inequality sign. And so for that reason, this is just evidence of the first when dividing by a negative number. I hope you see it and you are seeing the justification here. Okay. What if we were to multiply by a negative number? Shadeen, help me again, please.
All right. So here again, we are multiplying 3 by a negative 2. Negative multiplied by a negative number will also give us a negative solution.
Okay.
And 6 multiplied by a negative 3 will also give us a negative solution. So 3 multiplied by negative 2, negative 6. And 6 multiplied by negative 2 will give us a negative 12.
Awesome. Look at the orientation from the original inequality. Yes.
Let me ask you, do you think we are going to be seeing a reorientation or a reverse in the inequality sign?
I think so.
You think so?
I
Let's
think
see.
so. Simply because I heard you say negative 12 over here.
Right.
And I heard you say negative 6 here.
But most importantly, it is multiplying by the negative 2.
Thank you.
That makes
Thank
the
you.
reverse.
So let us look. Okay. We see that there is a repositioning of the numbers. Let's look at it. No longer is a 6 which becomes 12 no longer is it on the right.
No.
It has repositioned itself. And so to keep this true, to keep the inequality true, we have to reorientate the sign. In the streets, you guys say flip the sign if we are to keep the inequality true. Okay. Therefore, when we are multiplying or dividing by a negative number, we need to bear this in mind. When multiplying or dividing both sides by a negative number, it reverses the inequality sign. It reverses the inequality sign. And what that means is that it changes the less than to greater than, and vice versa, or it changes the less than or equal to more greater than or equal to. Please bear that in mind because, ladies and gentlemen, you will need that information as we go further. Okay? If you need to rewrite in your own words, please go ahead and do so. So let us see where this takes us.
All right,
Yes.
this takes us to trying to see if we can first read the inequation, and in this case it is read negative 3x added to 8 is less than or equal to 11.
Good. And how we solve it now?
All right, so we are still holding firm to what we did earlier.
3x added to 8 is less than or equal to 11. Yes.
11, and I hope that you are observing the inequality sign that's there, and you're also thinking about the number line, what the number line will
Would
look
look
like.
like. True,
right?
true,
So
true.
is it that we're going to be working with an open dot or a closed dot?
Thank you.
All right, so let's
Thank
move
you.
into solving. So it's negative 3x added to 8. We want to transpose, so we are going to be doing the inverse operation.
Yes.
And that is less than
11.
less than or equal to 11. And we are also maintaining the balance.
Yes.
So we also subtract 8 from the right hand side.
Because we did subtract 8 from the left hand side.
Good.
Okay.
So now we are left with negative 3x.
is less than or equal to. Oh, if you have 11 and you take away.
It's less than or equal to 3. I know some of you viewers, you are going to work that out mentally to say that the solution is a negative 1.
Yes,
But let
yes.
us do the calculations.
Yes.
So we are dividing both sides by a negative 3. What happens when we divide by a negative?
We just did the proof. When dividing by a negative, it reverses the inequality sign.
Right.
So therefore, the
X
less than or equal to now becomes
greater than or equal to.
Therefore, x is greater than or equal to 1.
Negative 1.
Oh, thank you. See? Negative 1, negative 1. Yes. And of course,
Or number line.
our number line, just to clarify our understanding, we will use, and you said which of the dots will we use again?
We
Because
have
it
a
has-
greater than or equal to, so we will be using the closed dot.
Okay. Okay. Oh, there you go.
Right.
So therefore, the solution for this inequality can be found anywhere right of the negative 1.
to include negative 1.
To include negative
Negative
1.
1.
Please don't be like me, remember it. To include negative 1. And the, okay, as is there, therefore, x is greater than or equal to negative 1.
Right.
To include negative 1. And what would the set bill, the notation be? What would it look like?
X is such that x is greater than or equal to negative 1.
Okay.
So it's no different from what we would have been doing earlier.
Yes, just bear those things in mind and be aware of what happens when we divide or multiply by a negative and do work accordingly. Okay.
Right.
So let's look at this one. We're still, in this case, I want us to look at what is here. How is it read? X divided by negative 2 is added to 2 is less than or equal to 6. Shadeen, I'm seeing addition here, but it says multiplication or divide and multiplying and divide. Where the division comes in?
The division comes in at the first term where we are dividing x by a negative.
For real, because division can be represented in a fraction form per se. Okay. Oh.
So now we are including multiple operation in the inequation that we are solving on the board.
Okay.
Right. So let's move ahead and viewers, don't be confused. It's simple, just as what we would have been doing before.
Yes.
We just need to pay attention to the operations that are being carried out in the inequation.
Yes.
All right, so we are going to be making x the subject of the formula, and while we are doing that, we are also going to be grouping like terms.
Okay.
So it's x that's divided by negative 2 that's added to 2 that's less than or equal to 6.
Yes.
Now, remember I said that we are going to be grouping like terms, which means that we are going to be transposing, and in transposing, we want to maintain the balance of the inequation.
Awesome.
So we are going to be subtracting 2 from both sides of the inequation. So we are left with
x negative 2 is less than or equal to 4. Okay.
Good. Now, that's where the division comes in.
Oh, yes.
And we are dividing by a negative 2.
Yes.
So we need to take into consideration what happens when we are dividing or multiplying by a negative number.
So right here, we, in order to get x as a subject, we're in fact going to multiply, because in the original problem, it says divide.
Right. Okay. So we are going to be multiplying both sides by a negative 2.
Okay, I get you. Therefore, that would be x is less than or equal to negative.
If we were to do that. But because we have multiplied by a negative number, then you say in the street we flip the sign, we do the reverse.
Yes.
So it's x now that is greater than or equal to negative 8.
Okay then. I see and I understand. I thank you for that. And of course, we go back to our trusted number line in order to clarify our thoughts. This is what it looks like on the number line. And because the inequality has the line at the bottom, we have the shaded dot because it says and equal to or equal to. And of course, the solution set written in set notation would of course be
x is such that x is greater than or equal to negative 8. So we are thinking about all those numbers that are to the right of negative 8 to include negative 8.
But guess what? Of course, here would have been the negative 8. Yes. Thanks for that, guys. I heard what you said. Am I not that good? Yes. Okay. Okay, then. So now we have looked at we have looked at all the nuances of first multiplying or dividing by a negative number when we're working with inequalities. We have used the number line to help us to represent the information. And of course, in the end, we use a set builder notation to show the solution set, which is a range of values.
Right.
So here is a sample question.
Right, so we need to build up now to the CSEC level where
Awesome.
we're actually going to be doing a sample CSEC question, right? So it says that we are to first solve the inequality 5 subtract 2x is less than or equal to 9. So we
Okay.
need to solve that. And
Yes, please.
we are good at solving now,
Yes,
right?
ma'am. So at least for the first part, we would have got the answer correct.
Right.
Not true? Yes, yes, yes.
So it is 5 and we're subtracting 2x and it should be less than or equal to 9. So while we're doing that, there are some things that it just pops out. The sign that's there suggests to us that we are dealing with a closed dot, right? And we examine carefully to see that we are not dividing by any negative just now.
Not no.
Just now, because we don't know what will happen further.
Thank you.
Right? So for just now, we don't see any division in the problem.
Okay.
So it would be transposing to make x the subject, 5, and we're subtracting 5.
Subtract 2x is less than or equal to 9, which would give us negative 2x is less than or equal to 4.
4.
Okay.
Now, here we have a negative. What do we do? What comes to mind right there?
I'm remembering that what do I do when I'm dividing or multiplying by a negative number?
Very
and
good.
When I look, I also have to bear in mind the inverse operation for what is there, because negative 2x is negative 2 multiplied by x, and the inverse operation would be division. All right.
Quite a mouthful.
Can I tell you?
So we are going to be
Learning.
dividing both sides by negative 2.
Yes.
So now x is, flip the sign,
Yes.
do the reverse,
Yes.
greater than or equal to
Negative 2.
negative 2.
So we would have that. The set builder notation says that yes, x, the set of x such that x is greater than or equal to negative 2. We will come back to this, and we're going to a break, to our final break, and we'll wrap things up when we return. Soon come.
integer. Integer,
Okay.
we are to determine the smallest value of x that satisfies the inequality in I above or
Okay.
1. Yes. Now, we did a solution to say that the solution set that satisfy this inequation or inequality is the set of x is such that x is greater than or equal to -2. We are now required to identify or to determine the smallest value of this solution set.
Yes.
Now, if we were to list the solution set, then we will be thinking about including -2, so it would be -2, -1, 0, 1, 2, 3, 4, and so on, right? So the smallest value for this solution set would be -2.
Okay. And we are justifying this on the number line.
Good.
So if we have this representation here in our solution, just by drawing a simple number line or writing the value as
solution set.
for the solution set, of course, you would be quite fine. And it's value 2 marks, but 2 marks go a long way.
Right.
So we would have completed that. Now let us look at
Another question.
another question that is similar to the one that we just did. We are solving the inequality -x subtracting 13 is greater than 36, right? And of course, from all that we would have been doing, we understand and appreciate the meaning of everything that is written here. So it's just us going through,
Right.
practicing what we would have learned to
Earlier,
this point.
right.
Okay.
So our inequality sign will jump out at us. No longer are we working with greater than or equal to or less than or equal to. In this case, it is greater than that we are working with. So we need to solve and then identify our solution set. So we are going to be making x the subject of the formula, and while we're making x the subject, we are going to be transposing and maintaining the balance of the inequation or the inequality.
Thanks. So it's 7x subtracting 13 added to 13.
So we need to transpose and we need to maintain this balance. So what are we going to be doing? We're going to add 13 and that is
greater than 36. Added to 13.
Right. Whatever we would have done on the right-hand side, we also do to the left or vice versa. So now it is -7x that's greater than...
That's what?
49. And we're also using something that we would have learned earlier. We are dividing by a negative
number.
So when we divide both sides by a -7, then x... the reverse of the sign is now less than -7.
And of course, -7 is not included in the solution.
It's not included.
Okay, I understand and I can appreciate that. Okay. Yes, that is what we have for our solution set represented by the set builder notation.
Right.
And of course, here, when we go to II or number 2 in this, it says the smallest value of x to satisfy.
And they are also requiring an integer.
Yes.
What is an integer? An integer is a negative or a positive whole number that includes 0. And it includes 0.
Yes.
So we are thinking about negative or positive whole numbers, and 0 could also be a part of this set. So it is the smallest value that we are to determine. 7 is not included. -7 is not included. So what would be... Right, we are moving to the left.
To the left,
so our solution would be, for II or number 2, it would be negative. and infinity.
Infinity. Because when I look at it, it's the line goes on, and of course.
Right.
Yes.
The
So,
further we move away from 0 or the more we go to the left of the number line, then we have smaller numbers.
Okay.
So it would be a negative infinity for the solution.
Awesome. So you would write a negative infinity, and that would be your solution or your answer for number 2 of the sample question. Now, we have been looking at mathematical inequalities, and some persons would have said, but where does this thing come from? I don't use it. I want to say to you that mathematical inequalities, they come and we see them in our lived examples. When we talk about the speed limit, of course, the speed limit on a section of the highway is less than or equal to 80 miles per hour. When we're working with our text messaging, or we are allotted a particular number of text messages per month, so it is the number of text messages per month is less than or equal to 250, right? And also the monthly payment on our credit card bills for our parents, and so it's 10%. The monthly payment need to be greater than or equal to 10% of your balance in that billing cycle. And finally, the time we need to walk from home to school, the distance for this example is less than or equal to 18 minutes, right? Okay, so these are lived examples where we speak about inequality. Now, before we go, we have one problem to consider to see how inequalities are actually used in our lived examples. So here we have an 18-wheeler truck, stops at a weighing station to see how heavy the truck is as it passes over the bridge. The limit on the bridge is 65,000 pounds. The front of the truck weighs 20,000 pounds, and the trailer, which is at the back, is 12,000 pounds when it is empty. In pounds, how much cargo can the truck carry and still be allowed to cross the bridge? Now, we have gone ahead and we've clarified this for you. We understand that the cab weight added to the trailer weight added to the cargo weight must be less than or equal to the allowed weight, which is 65,000 pounds. Good. So when we put all of that, now this is what we are expected to find, the cargo weight, which of course we don't know yet, and we're using a variable to show that this is unknown to us. When we would have done all of this, and you can, I want us to just look at it and understand the reasoning that goes through here. We see that 32,000 pounds added to X must be less than or equal to 65,000 pounds.
So it means that the entire thing, the truck, the front, the cargo,
everything
could be exactly 65,000 pounds.
Exactly.
But it can also be less than 50.
But not more, because it would not be allowed to pass, to go across the bridge. And of course, based on the conversations we've had before, Shadeen, you have taken us through the solutions for the inequalities, where X now is less than or equal to 65,000 pounds, subtracting 32,000 pounds. With that, the value of X would be 33,000 pounds. Therefore, what does this mean for us?
The solution set includes, or it is the set of X such that X is less than or equal to 32,000 pounds.
Awesome.
So we can have 500,000 pounds,
yes,
right?
Yes.
Or anything less.
Anything less would
or
suffice.
Exactly 33,000 pounds.
Okay. Well, boys and girls, ladies and gentlemen, that is all the time we have for this lesson. Oh my. Thank you so much for joining us today. Until next time, please keep safe.
I'm Simon Preston from TVJ. Thank you very much for watching our YouTube channel. To see our latest videos and also to see live events, click here. To see our full videos on onespotmedia.com, click here. Thank you very much for watching.